This is a solution to problem 75 from homework 3.4, day 1. And we're given a cubic function, f of x equals 16x cubed minus 20x squared minus 4x plus 15. And we can use the rational zeros test to find a rather extensive list of possible rational zeros. So let's do that first. So I'm going to do the rational zero test. And in order to do that, we're going to look for factors of the constant term, which we'll call p. So 15 is p, and constant and factors of the leading coefficient, which is q. So p is 15 and q is 16. So our possible rational zeros are going to be in this list. So the factors of p are going to be plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. The factors of q, which are 16, are plus or minus 1, 2, 4, 8, and 16. And I'm not going to generate the entire list here because that's not going to be necessary. Because the problem goes on and says when there's an extended list of possible rational zeros, use a graphing utility to eliminate some. So over here, you'll see I pasted in a graph. You'll put that into your graphing calculator. And from this, we can see that there's a 0 between 0 and -1. So looking at our list of possible rational zeros, those that are between 0 and -1 will be -3/4 from the 3 up here and the 4 there, and -5/8. Those are the ones that are between 0 and -1 that are relevant. It looks like it's greater than or less than -1/2, so I'm not going to test those. So let's try those two values and see which one is actually the 0. So I'm going to set up the synthetic division. Across the top row, I'm going to put the coefficients of f of x. So that's 16, -20, -4, and 15. On the outside, I'm going to put the 0. So let's go ahead. Let's check -3/4. So I'm going to bring down the 16. 16 times -3/4 is -12. -12 plus -20 is -32. -32 times -3/4, I'll do that down here. That's going to become 24. And then -4 plus 24 is 20. Then we have to do 20 times -3/4. I can simplify that, canceling out a 4. That's going to be -15. And 15 plus -15 is 0. If we had tried -5/8 or -1/2, those are the other options, they would not have been zeros. So based on this, we can say that -3/4 is a 0. And x plus 3/4 is a factor. Going from there, let's start factoring this function. So f of x is equal to x plus 3/4 times 16x squared minus 32x plus 20. I'm going to take out the GCF of the quadratic term. That GCF is 4. So I'm going to factor out a 4 here, and that will leave me with 4x squared minus 8x plus 5. I'll bring the 4 to the front, so that'll be 4 times x plus 3/4 times 4x squared minus 8x plus 5. And this is our function in factored form with linear factors and quadratic factors that can't be factored over the rationals. This is how we would typically factor. And now to find the remaining zeros, we need to find the zeros corresponding with that quadratic term. So really what we're solving is 4x squared minus 8x plus 5 equals 0. Because the leading coefficient here is 4, I would not complete the square. I would use quadratic formula. So solving this by the quadratic formula, we'd get x equals -b, which will be the opposite of -8, plus or minus the square root of b squared, so -8 squared, minus 4 times a, which is 4, times c, which is 5, all over 2 times a, which is 4. So this is going to become 8 plus or minus the square root of 64 minus 16 times 5 is 80. So minus 80 all over 8. We'll keep going here, keep simplifying. This will become equals 8 plus or minus the square root of negative 16 all over 8. And the square root of negative 16 is 4i. So this is equal to 8 plus or minus 4i over 8. We can divide out a 4 from all of the terms, and that will leave us with 2 plus or minus I over 2. And then we can rewrite that as 1 plus or minus 1/2 I. So to finish up, we're supposed to make a list of zeros, and we'll write that down here. So the list of the zeros are the one that we verified with synthetic division, which was negative 3/4. And then these two imaginary zeros, which are 1 plus or minus 1/2 I.